This is a tutorial on how to use the qdap package to parse through some abstracts for meta-analysis, make decisions about what to keep and what to throw out. First thing you'll need to do is download and install R and then the qdap package. Next, you'll also need two other pieces of software for reference management. Zotero, Google Zotero and download it. And Jabra, Google that as well and download it. This is for LaTeX, BibTeX type thing, and it's nice because it outputs a CSV, which R likes. Okay, go to your institution's database, and I'm choosing Eric in this case. Make a search. I'm going to use reading comprehension, and you'll, depending on your meta-analysis, choose those terms ahead of time. And here we get almost 18,000 results. First thing you should do is page options, display 50 at a time, just to make your life easier. And we don't want to parse through these now. We use qdap to help us with that. Here I have alert, save, share. I don't know what your university does, but we can ship those to a folder. Results just shipped into a folder. Go to the next page. Do the same thing. Ship them to the folder. Here that folder is over here. Review it. You should have 100 results in that folder now, which we do. Next thing we're going to do is export it. And we're going to export it as an RIS format. That's what Zotero likes, and it will download it directly. I'm using Chrome, so I can just click here and open it up using Zotero automatically. And right off the bat, we're going to export it for Jabra. Go to Export Library. BibTeX is what we want here. It doesn't say that, make it say that. And we're going to go ahead and call it new 2. We're exporting it, and let's go open that up now. Right here it is. Open it up, and right away we can go to File, Export, and here's where we're going to make our CSV. Make sure that this file type says open off a CSV, and we'll call it new 2 again, just for consistency. We've exported it. Here we have a nice CSV of that now. Now you can open up R. First thing you do is load qdap. I do options with equals 10,000 because we're dealing with text data. Read it in with the read CSV function. And let's look at that using the htrunc function from qdap. That's the head of it, first 10 rows. And what columns we're really interested in tend to be custom. So custom 1 through 5, the abstracts tend to get thrown in there in some shape, form, or another. You'll have to, each search will be different. And what we're going to do is paste those together into one column of annotation text. Next thing we're going to do is figure out what those columns are, or what numbers of the index they are. And for that we use names, or you can use column names equals custom 1, and then also custom 5. And then wrap that with a which. Check out what it does. It tells us, oh, column 27 is custom 1. And column 31, use a colon separator. And that gives us some indexes of 27 to 31. We now feed that to X for indexing. And we can tell it take just those columns, which we'll do right here. I mean, it's huge, but we have just those columns. All right, next we're going to make a data frame with that information. First thing you do is an ID column. This is good for sorting, 1 through n row of X. Then we'll take the first 10 columns of X. That was from bibliography to year. That's kind of important information. And then we'll make the abstract. This is just some regexing. It's not necessarily useful for your purposes, but here it is for me. But the important thing is this paste to function from qdap with the X and the indexes. We'll paste those columns together. So you have one column with it all pasted together. So we can run that, create a Z data frame. Let's look at that. Trunc df, and you'll see our last column here is the abstracts. Okay. All right. Let's start doing some searching. Next thing we'll do is turn that abstract column into character with the as character, and then we're going to split and we're going to remove things that don't have an abstract. This one here, for instance, doesn't have an abstract. And the way we do that is the scrubber function from qdap around z abstract, and we're looking for blank or single spaces. The scrubber will turn all multiple spaces into single spaces. We're going to split on it. You'll see most everything did have an abstract, but these four didn't. We're going to need to look at those closer, go find those files or those abstracts and or those downloads from the database and see if they have an abstract, or if we can find out more information, should we include them in the meta-analysis. Next, we're going to look for some terms within those abstracts. And what we do is we make categories of lists. So I'm looking for brain stuff and I'm looking for reading stuff. And so you start with, call it something, it doesn't matter, but matches equals and then list. Okay, this is a nice way to format it. And then brain equals, and we're going to make a vector of words that have to do with brain. Okay, and do the same thing for reading. And here's a vector of words that have to do with reading. Okay, notice that all of them start with a space at the beginning and no space at the end. Here's why. Termco functions will look for it'll match a space followed by this brain and then anything after it. So we'll find brains, brained, braining, brainy. If I did this and put a space after brain, now it will only find brain. If I didn't have the space in front of read, for instance, and it said this, it would actually find the word bread. We don't want that. Okay, so you got to make some decisions there with the list you make. Go ahead and run that. Let's look at what it looks like. And it's a list with two different vectors in it, a brain vector and a reading vector. All right, now we can use termco A. With the abstract, notice I put with, and then V1 was we split up here and we found the ones that did have abstracts. Okay, and so we feed to it abstracts, termco A, we feed to abstracts, the ID, and then the match list of matches. Let's see what that looks like. Okay, took a little bit because searching through those abstracts. Let's look at the top of it. And you'll notice that it found all those words that brain, cognition, explicit, and all those things and combined them into one term of brain. And the same thing for reading. If it has a 0, that means it didn't find it. A 9 means it found 9 reading terms within this particular journal abstract. Okay? Perhaps you don't want them all combined. You don't want brain, cognition, explicit all combined. You just want a list of all the words and you'll make those decisions. Okay? What we'll use then is termco D. And instead of match list, we use match string. And we can't use matches because it's in a list, so we'll just unlist it. You see what unlist does? It just turns into one vector. All right. Let's go ahead and feed that to termco D. Let's look at that. You notice by default it prints out the frequency, and then also this is this percentage of words in that abstract that were that term. Okay, so 5 cases of read, 2 cases of comprehension, 0 case of strategy. Okay, you use that to make decisions. All right. Also, something to be aware of is the termco to short term. By default, termco prints out column headers with term in them. Termco to short term makes it so that those terms in the column headers go away. All right, start actually doing some parsing. Let's look at the raw output, and you can see from termco A, you can see brain and reading, and you can start making decisions. Look at this column, and we'll say anything. Let's look at both these columns, and what we'll do is look for any hits. And what we can do there is say termco to short raw, take the index of 3 to 4, that's the third and fourth column, and we'll do row sums for those. And we're looking for anything greater than 0, and it'll give us a logical vector. We'll call that all. So now we have a logical vector. And we can feed that. You can see a false here. You can feed that back to Z, which was that data frame we created above, as an index, and it will return only those that were greater than 0. You can see how you can do some parsing. You can also write it out to a CSV so it's easier to see with a write table. This has been a tutorial on how to use qdap to parse through abstracts for meta-analysis.